Welcome to the Virtual Foundry podcast.
Hi, everybody. Welcome to the Virtual Foundry podcast. This is volume 3, episode 8. Today is Monday, August 1st, 2022. The time is 10:53 a.m. and the temperature today is a kind of a warm 75 degrees. That's 24 for you Celsius users. I do feel a little weird saying that 75 is warm, but we are headed for a few warm days here, and we have really been spoiled with a nice cool summer. I think we are the only people in the Northern Hemisphere who can say that. So I am relishing every second of it.
Yes.
Today, we're going to be talking about cleaning your part after sintering. I'm Tricia Cease, president of the Virtual Foundry, and here with me as always is Brad Woods, founder, inventor, and all-around science guy. Say hello, Brad.
Hi, everyone.
So once your sinter cycle is complete, you've got a full metal part, and it's really exciting to dump out your crucible and check out your part, but they don't come out of the sinter cycle all shiny. Now we're going to show you today how to get them there, but Brad, what is that stuff that's on the outside of your part? Why isn't it shiny when it comes out of that crucible?
The surface is dull for a couple of different reasons. The primary one is that they're made up of millions of microscopic spheres, that they look flat visually, but they're not optically. They're large enough they're not reflective. So the light hits it, it bounces off in all different directions. For it to be shiny, the surface has to be level, flat. And kind of the second thing that affects it is our sintering technique has you burying the part in granulated aluminum oxide, and the particles pick up some of the texture of the grains from the ballast itself.
So how can people get their parts to that nice shiny metal?
Right. There's a couple of different strategies here. The easiest one is to take a brass wire brush and just scrub at it a bit. This takes some elbow grease. It can be simplified by using a wire brush on a bench grinder. This is a great strategy. And this will get you to a part that looks metal. It won't have a mirror-like finish, but it looks like a piece of metal and it looks very nice.
So we have a video prepared of the process of getting your part out of the crucible and then working through a few different techniques to apply that shine.
Okay, so this is a small stainless steel crucible. This is a part that's already been sintered. So this was run the night before I came in this morning, and this is it and ready to go. And it's just a simple stainless steel cup typically used in kitchens and things like that. And we sell these on our website. It's filled with granulated coconut carbon. So it's activated carbon. And the black that you see is that carbon. And this is a sacrificial material that will absorb any oxygen that's present in the crucible. So let's take a look. So here, just dump it out. And this is just a bronze sphere that I 3D printed. Okay, so this bronze sphere, I think, I printed this. This isn't 100% dense, but it isn't hollow either. So it's probably about 80% dense as far as the 3D printing infill goes. And this is typical of all of our parts as they come out of the sintering process. It has some carbon stuck to it and it just looks a little bit grungy. But at this point, the part has all the properties of the metal that it's made of. So this is bronze. So it'll have electrical and thermal properties very similar to any other bronze part, or a bronze part created in any other method, whether it's cast or forged or machined or what have you.
Now, you talked earlier about using a wire brush, and that is going to be shown in this video. But first, we're going to walk through using a tumbler to get to clear the part off and get it to a nice finish.
Right. And actually, if the part is something that fits in a tumbler, This is the easiest way to do it. We just throw it in a tumbler with some stainless steel tumbling media and leave it there for maybe 3 hours. And at the end, you have a very nice shiny metallic part. So let's take a look at, first we're going to talk about, okay, let's start the video. So I'm loading the tumbler. This is stainless steel media. And the whole point here is this stuff it has various shapes that are meant to get into any crevices and things like that as you're tumbling the part. We add some water. And this is just dish soap, just Dawn dish soap. About a 1/4 cup of ammonia. We've found that ammonia works really well, especially for the copper parts and copper alloys, bronze and copper. It dissolves a good layer of oxide off the top and just cleans it up really nicely.
You're using regular off-the-shelf dishwashing soap and
Yep.
regular off-the-shelf ammonia.
Correct. The dish soap is just Dawn, literally the brand name. The ammonia is store brand, either, Dollar General or Walmart or wherever I happen to be that day. Okay, so what's happening here is kind of interesting. All of those, that stainless steel tumbling media is having the effect of millions of microscopic hammer blows. And a few interesting things happen here, things that are more interesting than you might expect. There's actually a level of surface hardening. So as these tiny metal objects are colliding with the part, they're actually literally driving the atoms closer together. So it will make the very surface of the part harder. The general concept is called work hardening. If you go out and just Google the words, you'll find tons of information on it. And it's a very important part of all of working with metal, and especially, well, not especially, but in 3D printing, it's important. It sets it up so that the harder surface will take a more mirror-like polish, and as we progress through the process. But these tumblers are inexpensive. You can just go buy one from Amazon. They're, I think, $100 on the high end. The tumbling media, there's an infinite variety if you go out shopping for it.
Right, so this is a pretty standard tumbler and pretty standard tumbling media as well.
Yeah, these things are inexpensive. You can buy, like anything, you can spend as much money on a tumbler as you want, but you don't need to. So just to keep things simple, expect to spend maybe $80 to $100 on a small one like this. The larger ones, which have about double the capacity, are about 150.
And you keep this going for about 3 hours?
Correct.
I
And
know sometimes you turn it on and leave it overnight. So
Yeah.
just the length of time, you want to do it at least a few hours, but longer than that is just fine.
Right. I think it's kind of a to taste kind of a recipe. It's how you want your part to look. And it really doesn't hurt it to go too long. There's really no downside.
And between the water, the dish soap, and the ammonia, the ratios of those or the amounts that you put in, how precise do you need to be with that?
Not very. You don't want to put too much dish soap in it. It'll inhibit the sort of the friction between the particles. So on the dish soap side, picture 3 or 4 drops, literally drops. With the ammonia, it was probably a 1/4 cup, but you really can't use too much, and not likely that you'll use too little.
Okay.
Okay, so this is actually an alternative method. So in this one, I have a brass wheel on our bench grinder, and this works, but it's a mechanical process. So you're handling the part more. there's a bit of risk involved in working with a bench grinder anytime you work with a bench grinder. But if you take a look, so what it's going to do is the wire brush is just smoothing off the surface. So like I said before, the surface right now is made up of millions of spherical particles, which diffract the light as it hits it. So we're just trying to flatten the top off of those spherical particles and create a level surface that light bounces off of without diffracting. And the smoother you get it, the more mirror-like it is. And this is just enough to show you, just enough to make the point. So there, it's metal. It's a very striking bronze color underneath. So we're going to show a part here. It's a flange that I made for our extruder. So I can connect a flexible hose to the throat where materials go into the extruder. This one has already been wire brushed at this point, and now I'm taking it over to our buffer. So this is a buffer. It's just a simple, we call it a sewn cotton buff. And there's an infinite selection of polishing media. We like ZAM, and we recommend that you stick with the ZAM. In most strategies for polishing, you have to go through several different steps of media. You start with very coarse and work towards very fine. We've found that ZAM kind of splits the difference. We can start with a pretty rough part and get it to a high polish without having to go through multiple different types of media.
So the part has gone through the tumbler, or it's been treated with the wire brush. Something else should be happening before you get to this part. This is going to apply a final polish to the part.
Correct. So this is going to take it up to a mirror-like shine.
So you're applying the ZAM directly to the buff there.
Yes. And the way to think about this, not sure how far we want to go into buffing, but the wheel itself doesn't do anything. All the work is done by the buffing media. So you load the media into the cotton buff, and then it's the friction of the media between the cotton buff and the part that brings up the shine. So when I started here, it was wire brushed. When I'm done here, so this is again, here, let's talk about this a little bit more. So this whole process can be done with a Dremel tool. This one is a flex shaft, which is sort of like a pro version of a Dremel tool, but really Dremel tool would be just fine. And I use it here just to get the inside of that, but you could easily do this whole part with a Dremel tool, and it's the same concept. It's a cotton buff, and it is ZAM.
We can see this part looks really shiny. You can see the print lines in there. The part held that level of detail all throughout the debind and sintering process as well.
Right. And this one, so often we recommend that people print in a near net shape type strategy. As we're improving the process, and with our currently published process, this part was printed net shape. And it isn't highly precise because the holes are oversized, and there's room for sort of slop in how the holes line up. But it's pretty impressive. We can print net shaped parts, and this is bronze. And we do this consistently with bronze and copper. We have these two processes completely, I guess you'd call it mature. These are just ready to go, and they work great.
So we saw what the part looked like coming out of the crucible. It was sort of dull, but still metal. Now, what if you dump out your crucible and your part is totally black, and maybe it falls apart a little bit as you handle it?
Right. So this is a failed sinter, and if it's black, it's been oxidized. So, we're working with bronze here, and the only thing that can be black is cupric oxide. So if it's black and crumbly, oxygen made it into your system at some point. And you can usually tell as the part comes out of, let me try to get to here. Okay, so the part that I'm pointing at here, if this was a failed sinter, this would be white. All of the, and underneath it, this black carbon would have been consumed by too much oxygen being present. It would have been, and it would have then literally simply, burned up, and then oxygen got to the part and prevented it from sintering. And this is probably the most common problem people have with the sintering process, oxidation.
Now, what is that thing on top of the crucible there?
So I just put, like we use sintering paper. This is just a chunk of a broken fire brick. I'll just lay something on top of it, and where it prevents oxygen from contacting the carbon, it preserves the carbon. So I've been using the same carbon for months. As long as you're careful and you cover it up so that it can't be consumed by the oxygen, you can reuse it indefinitely. Each time you use it, a little bit gets consumed, but really not very much. So you can set up your system to use the same sintering materials, literally dozens of times. Like I said, this same carbon, I've been running this for probably several months. And occasionally I'll take it and put it in a sieve and just get the gunk out of it and kind of clean it up a little bit. But if it's black, it's usable.
If it looks coming out the way that it did going in, you've got good carbon, most likely oxygen did not reach your part, and you'll have a successful sinter. So covering the crucible really helps limit the amount of oxygen that sintering carbon has to deal with.
Yep. And one note, normal, when this comes out of the kiln, there will be a light layer of white on it. That's just where it was doing its job. It consumed some oxygen that was present. But if you stir this slightly underneath it, the carbon will be rich black.
So Brad, pretty simple techniques for getting your part to be nice and shiny and pretty. A wire wheel brush on a bench grinder, even a handheld wire brush, you'll have to work at that a little bit harder. Tumbler, a basic tumbler with a few basic ingredients thrown in there. And then finishing off with a cotton sewn buff and some Zam polishing compound, either again on a bench wheel or using a rotary tool.
Right. And most people don't need their parts to be mirror-like. And the flange for our extruder probably didn't need to be highly polished, but it looked pretty cool. So it's kind of,
it does look really cool. Brad, I do have one more very important question for you today before we wrap up.
All right.
What kind of car is a Viking's favorite?
I keep thinking I'm gonna get one of these, but I haven't yet, and I have no idea.
It's a Fjord Explorer.
Nice.
Well, thank you for joining us on the Virtual Foundry podcast today. If you've got a topic you'd like us to do a deep dive on, let us know by info@thevirtualfoundry.com. And if you are working on something really cool, we'd love to interview about that. You can showcase your project in this format. Again, info@thevirtualfoundry.com. Let us know what you're up to. In the meantime, like and subscribe the Virtual Foundry YouTube channel, and we'll see you next time.